All right. So officially, midterm exam will be on Friday during our normal class time. All right. It's going to be on Blackboard. So I expect that you will take it during class time on Friday. Now, if for whatever reason you would like to take it earlier, it will be available on Blackboard starting right after class today. Now, once you start to take the exam, you got to finish taking the exam. So only take it early if you're ready to actually take it. Okay. Now, what I'll do is I'll make sure I'm live on Slack on at class time on Friday. So if you're taking it and have real-time questions, I'll be available to field real-time questions for about the exam. I don't anticipate that being a problem, so maybe don't let that be your major deciding factor when you're deciding when to take the exam. But if it would benefit you to take it earlier than Friday morning, you may. Just don't come back to me and say, oh, I forgot to study for it. Can you reset my exam so I can take it again? There you go. You got one shot at it. All right. Exam will be 10 questions, all short answer essay, no multiple choice, no true false. There will be at least one conversion question on there. So convert some number from, binary to hexadecimal or something like that. Or it could be a convert from a size, some kilobits to gigabytes or something like that. So you should know both of those skills. So it'll be at least one of those questions. Each question will be worth 10 points for a total of 100 points. The exam is designed to take probably about 35 minutes, but you have an hour to take it. So there should not be a major time stress thing. I think I only have, I want to say 3 of the questions are programming questions. I think that's right. Just because those are going to be the ones that take you a little bit more time. It's either 3 or 9. All right. Any questions about the format of the exam first, before I just kind of flip through here and kind of tell you what I think is important and what I think might be not quite as important? All right. Now, as a starting point, remember that this class is cumulative from last semester. So I expect you can still write a for loop and all the basic programming stuff. Okay. So the coding questions are probably going to have you manipulating a string, dealing with an array, doing things like that. So those are things you should be able to do in Java. The syntax, as you've already seen, is very, very, very similar to the syntax in C++. But I'm testing you with some of those programming questions to make sure that you're gaining aptitude in coding. Remember, I still have the policy that if you bomb the midterm and you do better in the final exam than you did in the midterm, I'll replace whatever score you got in your midterm exam with what you got in your final exam. So if you get a wake-up call here in the midterm and you get a 10% on it, you can still fix that by doing better on the last one. All right, and this exam will only cover through the end of Java. Nothing about Unity is on the exam. All right, so that's us ramping up for the next thing. All right. Definitely understand the role of pointers in Java. Understand that they do exist. We just don't have a syntax specifically for them, yada, yada, yada. Be able to work with strings. In Java, understand the how to compare strings to each other, understand the charat method, the length method, and know how to concatenate strings. That probably gives you, I'm not going to ask you anything on the test that makes you have some, strange string method memorized. If there's something that I want you to use that I didn't introduce, I'll give you the documentation for it. And since you all know how to call class methods and non-class methods, you should be able to call anything I give you, right? All right, so but be able to use strings. I do like to ask programming questions that have you do something with a string. Take a string as a parameter, do something to it, return a new string, take an array in, do something to it, make a string, add a string, whatever. I kind of like those kinds of questions dealing with collections. All right, go ahead.
That special string that can have like something.
Oh, this thing here?
Yeah.
Well, I mean, that I think if you remember, it was something like this. If I would have say string s is equal to new string hello versus string s is equal to hello. This is how you create an instance of every kind of object inside of Java, and it is allowed for strings, but string gives us a special kind of syntax like that, so we can kind of use strings like they're primitives. But remember, we did talk about how they aren't identical to each other when we had the discussion about that double equal sign, comparing strings.
Dot equals kind of thing?
Yeah, if you want to compare the contents. All right. So this slide may be important. Hint, hint. So is this slide. Hint, hint. All right, so then we kind of reviewed what we did last semester, so we can start rating the Java version of it. I'm not going to ask any questions specifically about our dungeon crawler. The questions are programming-centric questions, not something about how, you know, exits work in our implementation or something like that. Definitely understand static versus non-static. Static being class methods, non-static being instance methods. Know how to identify them when you see them being defined. Like when we looked at the Java documentation and we could tell how do we call this based on whether or not we saw the word static there or didn't see the word static there. Also be able to actually call those methods. So be able to write static methods or class methods, be able to write non-static or instance methods, be able to call class methods, be able to call instance methods. Know the difference between those. Understand public, private, protected. What are they for? Why do we make all fields private initially and then loosen the reins, that kind of stuff? Understand the role of protected when it comes to inheritance. Understand the inheritance model, the idea that all objects, if you don't do anything, extend object. Otherwise, you can extend classes that you've written. Understand the role of the abstract keyword. Know the super keyword. You know, this is how an object refers to itself from within itself. Super is how an object refers to the instance of its parent from within itself. Nothing about that. I don't think I asked you anything dealing with the instance of operator on the exam. You should know about it, but I don't think I test you on it. Definitely abstract keyword. The idea of blocking versus non-blocking code. This was our discussion with threads. Kind of what's the role of threads? What does it allow us to accomplish? As opposed to what wouldn't we be able to do if we didn't have access to something like a thread? So understand code that blocks versus code that doesn't block. I don't think I asked you anything about interfaces. They're interesting, they're important, but I wouldn't call them a super important thing for the exam. Okay, and then I think we're back to where we were. All right, questions about anything? Go ahead.
Just in short, like the abstract keyword again.
Abstract keyword is, well, if a class is abstract, that means we are not allowed to create an instance of that class. And it pretty much exists for us to define a class solely for the purpose of inheriting from it. So for example, our inhabitant class in our dungeon crawler, we've decided we're never going to have just generic inhabitants wandering around. So we never would actually want to create an instance of inhabitant. Therefore, it would make sense for inhabitant to be abstract. We'll still extend inhabitant with our monster and our player. Those would be non-abstract classes. So abstract is kind of like a self-policing type thing. It's near where it says class. You can say public abstract class. I think you could actually say abstract public class too. I think the order of those doesn't really matter. Those are modifiers on the class. That's right answer. Other questions? Yeah, go ahead.
Someone, will you need us to be able to write threads and do error handling, or just?
No exception handling in it. Trying to think about one of the coding questions. You should definitely understand the difference between the run method for thread and when we call start for thread, like what the difference is there. I don't think I actually have you write any code that has you like create an application that has some thready stuff in it and then some other stuff and spawn off threads. It's kind of a little bit big for a single question. Yeah, so it's I would say there's probably not a lot of coding around threads on the exam, but you should definitely know about them. Maybe one of the non-programming questions will deal with that. Other questions? Go ahead.
I think you might like have like a question.
Possibly, yeah. I could give you a if I show you some code and say what happens here, could be like a question dealing with blocking or non-blocking. So you understand that, you can show me that you understand that a thread is cooking in the background while this other thing is running, that it's not blocking you from doing it. So that would be a fair game type question for me to show you some code. And then you tell me, what does this code do? Keeping in mind, just like last semester, I'm not asking you to go line by line telling me what each individual line does. I want you to tell me roughly, what does this function accomplish? All right, other questions? Go ahead.
So can you explain how like the Java pointers work and like so that?
Well, yeah. So I mean, when we created an object in Java. So right off the bat, do I have one of these guys open? Oh, that's another thing. Let me just open up one of my stuff here. Oh, it doesn't matter. I'll just do it in. So if I say something like player P is equal to new player, and then I say system.out.println P, this guy is going to output a memory address. Right. So the idea here is that pointers do exist in Java because we can get to memory addresses in Java. That's what a pointer is. A pointer is a primitive type that knows how to hold a memory address. What we don't have in Java is the ability to specifically use syntax around pointers. So we can't say something like star P or the address of P. We don't have those syntaxes in Java like we did in C++. All right. So a lot of Java textbooks talk about, oh, pointers don't exist in Java. It's kind of like this feature of, you know how you hated pointers in C++? Well, now they're gone because you're in Java and they don't exist anymore. I promise every single time you see the new keyword in your Java code, pointers are afoot. All right. There are pointer things happening. New memory is being created, and that memory is being stored inside of this variable name. What we don't have in Java is the ability to directly manipulate that memory. It gets done for us. Java makes those decisions for us. So it's not fair to say that pointers don't exist in Java. It would be fair to say that we have less direct control over memory in Java, or Java makes more decisions for us, which 99.9% of the time works out. But every now and then you want to be able to do something weird with memory, probably because you're doing something that you probably shouldn't be doing, but but whatever. That makes sense? All right. Other questions? Someone else?
Yeah, static and non-static, like, first of all, is that going to be like general, like static for anything, or just like that way?
Well, we're talking about defining methods.
Field.
Well, fields can be static and it follows the same rules, but on the exam, the focus would be static versus non-static methods, even though the answer is the same for both of them. But you can focus on it from a method perspective.
And then also, you explain the difference between that.
Okay, so if we are defining a method and we want the method to be owned by the class, we put the word static in front of it when we define it. So we'll say static void do something. And when we do that, when we have the word static in front of it, we call that method using the name of the class in which that method was defined. So if a method is static, we use the class name to call that method. If we're defining an instance method or a non-static method, we still write a method, we just don't put the word static in front of it. But when we have a non-static method like that, when we go to call it, we must first create an instance of the class in which that method was defined. We can't just call it with the class name. So, for example, strings have a non-static length method. So we don't say string.length, we say s.length, s2.length. And the length method of S knows how many characters are in S. The length method of S2 knows how many characters are in S2. As opposed to, similarly, strings have a to uppercase instance method. So it's a non-static method. We call that by saying s.to uppercase or s2.to uppercase. As opposed to the character class has a static to uppercase method. That means it's owned by the character class itself. So we call that method by saying character dot to uppercase, and then we pass it the thing that the char that we wanted to convert it to uppercase. So those are two examples of methods that basically do the same kind of thing, but one of them was written as an instance method because it operates on the different values of strings. And the other one was written as a class method. I think I probably called it something like a factory type method when we talked about it, where we use the character class, which exists once, and we use its factory method called to uppercase, and we just toss the chars we want to convert to uppercase to it. So that's an example of that guy being a static method. Go ahead. Well, not necessarily. It just would be more common, maybe not to need parameters, because at the very least, a non-static method at least knows about the instance that called it. So to pass it more than that would mean you actually did need more than that to accomplish the goal. But at the very least, a static or a non-static method or an instance method, it knows about the dude who called it. Whereas a class method, like to uppercase for character, it doesn't know anything about any value because the class is just it's a non-entity, right? It just has that, it doesn't have a core value.
Like you ask him, like, are you not able to pass him like specific fields?
They're identical. Class methods and instance methods look identical from a legality perspective. I mean, how you write them, you might for instance, like his question, like he asked, well, does that mean you'll never have parameters for instance methods? You might, because you might need extra stuff. For instance, the index of method or the char at method of the string class. Char at takes a number. It knows about the string, but it wants to know which char in the string are you asking me about? S.char at 4 gives you bucket 4 of what's in that string. You knew about the string, but you still had to provide it some additional information so you to get to what it was doing. A method is a method. It doesn't matter whether it were static or not static. The difference is whether we put static in front of it dictates how we intend for that method to be used and called. So if somebody else wrote the method, like when we're looking at the Java documentation, if it's got static in front of it, that tells us how we have to call it. We have to use the name of the class in which that method was defined. So we can scroll up, look at the name of that class, and that's how we call that method. If it doesn't have static in front of it, that means it's an instance method. We know that we first need to scroll up, look at the name of the class. We need to first create an instance of that class, and then we can use that instance to call that method. It's the point of one or the other, which is similar to like that character 2 uppercase versus string 2 uppercase. It's they made the 2 uppercase method in the character class static because it only needs to exist one time, and instead it serves as a one-stop shop. We can throw chars at it and it spits out the uppercase version of those chars. And the reason they decided to do that for the character class is because we already have a way of holding chars in Java. It's called the char primitive type. Primitive types can only hold a value. They can't do anything else outside of holding a value. So it makes sense that we might want to have some classes out there that allow us to do things to chars. As such, there's a class called character. And inside of that class, there's a whole bunch of, in this particular case, static methods that knows how to operate on char primitive types. So it made the 2 uppercase method, for example, in there static, because it wants you, if you want to convert an A to uppercase, you would say character dot 2 uppercase A. That's why they chose to make that static. If I'm dealing with a string, we don't have strings as primitive types. So we actually create instances of strings. A string holds the value. Okay, string holds hello or world. If I want to convert hello to uppercase, I don't have to say string dot 2 uppercase hello. Instead, I would say string s equals hello, and then I'd say s dot 2 uppercase. That instance method, the non-static method 2 uppercase, knows about s. It knows that s holds the string hello. Okay, so that comes down to is what values are you operating on? It doesn't make sense for this to be static or non-static. One is not better or worse than the other. It's whatever's the right tool for the job. Okay, so when we're writing it ourselves, we get to make the decision. And you could, in many cases, you could just have an argument with yourself and come out either way with a decent argument. When you're looking at documentation, you're at the mercy of how they wrote it. If you go and look at the documentation, if you see that word static out front, that tells you exactly what you need to know to call the guy. The static is there, you use the name of the class. If it's not there, you use an instance of the class. Make sense? All right, other questions? Okie dokie. All right, so like I said, the exam will be up following class today. So you should be able to see it. You can take it whenever you want, but I will assume that a majority of you are taking it during class time on Friday. I'll be live on Slack at that time. If you have any questions, I'll answer them right away. You have an hour to take the exam. It probably won't take you that long, but you have it. For the conversion questions, make sure you show me your work, or you risk if you give me a wrong answer and I have no work to look at, it's just going to be a 0 out of 10 as opposed to maybe an 8 or a 9 out of 10 if you made a small little math mistake.
Did we send your work just through Slack?
You can, or you can take a picture of it and upload it through it. You can email it to me if you want. It's up to you. I mean, you can include it with the question. I think you can upload an image with the question, but whatever is best for you, it's fine. If you have your scratch paper afterwards and you want to email it to me after the exam and just say, hey, here's my work from the exam in case you need to reference something for partial credit, that way I'll have it in my inbox for when I'm grading. You might need to, you do it that way, you might need to remind me after you get the grades, because I grade with names off. I grade one question at a time. So if I don't have work in line there, I might hit you for more points off. And then you'll say, hey, I only made this mistake, but if I have your work in my email, I can go back and fix it after the fact. Okie dokie. So we will not meet in person on Friday because you'll be taking your exam at that time unless you have chosen to take it earlier than that under your own whatever. You could take it this afternoon if you want to take it this afternoon. Nothing's preventing you from it. Several people are leaving early for break, so they needed to take it. There's some sporting events going on as well, so they needed to take it. So I just made it available for everybody to take it. What the intention is to take it during class on Friday, where I can make sure I can answer any live questions or whatever, but you don't have to come here. It's all online. It's on Blackboard. It is closed book, closed note, closed neighbor. Don't work on this in groups. All right. Okay. So let's keep cooking here. I think we're just ready to start adding some physics to our rigid bodies. Create a new script. So is this what we're at? The apply input data to the player?
In the last video, you wrote a declaration for the onMove function. Next, let's use the method get to get movement input data from the sphere and store it as a vector2 variable. In the space inside the onMove function, add the line
we talked about vector2.
Vector2 movement.
All right, so here's where you apply the force. The force.
Next, let's start to write the code for adding force. In the function body, add the code rb.addForce inside opening.
So just as a quick reminder here to catch everybody up mentally, remember here in start, we went ahead and extracted the component of the game object that this script is attached to, which is our player. We grabbed its rigid body component. We stored it inside of a global variable from line 8 here, rigid body. We made it private because we only need access to it inside of this class. All right, so we gave it its value here in start, kind of like a constructor. Start gets called once when the game first starts. So now RB is accessible anywhere inside of our program here, and it holds the rigid body component of our player game object. So here on move, this is a callback from our new input system that Unity has now, which we'll see if it's better or worse or whatever. All right, so this guy gets called whenever something has changed with an input value. All right, so the very first thing we're doing here is we're going ahead and extracting from that input value the vector2 component, which is going to be the XY position of it. Actually, I think I said last time, it doesn't actually have to be an XY. A vector2 is effectively a collection for holding two things. You can put whatever two things you want in there. I think they're floating point numbers. Any two floating point numbers can go in there. All right. And then remember that the fixed update is something that happens 60 times a second. And what she's starting to do here is she's starting to take that rigid body. So that is the rigid body component of the player object. And we're going to be adding some force to that guy, applying physics to it. And that physics is going to be done probably based on the math of this movement vector. So let's see where she goes with this.
in closed brackets, type movement vector, and then end that line with a semicolon. You'll probably see in your script editor that there is an error on this line.
All right, so let's. All right, so here's my fixed update in mine. So I'll say this dot RB dot add force. And the add force, notice she says, you know, she's going to put in input vector. And she's complaining about an error. Why is there an error on that line? Go ahead. Yeah, the scope of input vector is not here. Input, so input vector was a local variable we defined right here. So it lives and dies inside of onMove. Now, onMove, this guy gets called whenever there is input detected. So I don't know if it's using the arrows or the WSD keys or whatever, but whenever there's whatever the input system thinks is input, onMove gets called as an event. Fixed update automatically gets called 60 times a second. Okay, so it's like its own thread. So variables that were defined locally inside of here are not accessible outside of here. So how do we fix that? How do we make this variable available inside here? Well, fixed update takes no parameters. Well, so we can do like private vector2. Call this guy input vector. You probably actually it's a primitive type, so I don't know if you can set it to null, but you wouldn't have to. But probably it's what you just said is a good question. It probably would be correct programming. I think it's vector2 dot. Is it an identity? We don't have a vector2 null thing. There's a vector3 identity that's like, you know, basically just nothingness. No, just leave it alone for now. But yeah, so we could just create a new vector2 for no good reason and give it 0, 0. So that would be the vector2 with forces going in 0 directions. So that's what our input vector currently is. Presuming it's going to work the way that I think she's angling towards here. All right, so we make input vector global here. We still make it private, so it's only accessible inside this class. We give it an initial value inside of start just because we are following good programming practice. So it has a value. Whenever onMove does get called, we update that value to whatever the vector2, the updated vector2 component is. And then inside a fixed update, again, I like to say this dot, just because that's what I like that. But variables resolved to their most local definition. Input vector is not defined locally here. So the next place it's going to look is at the next most global scope. Well, let's see.
There are 2 reasons for this. Firstly, the variable you are trying to use is a vector2, and you need to give this method a vector3 variable. Vector3 variables store data across 3 axes, x, y, and z. These values will determine the direction of the force you add to the ball. If you head back to the editor and look at the global gizmo, you can see the arrows also indicate this. To resolve this issue, you need to create 2 new variables for the individual input directions. Underneath the rigid body variable you created, add 2 more variables called
think what she's going to do here is she's going to use the vector2 to get direction. And then she's going to have another variable that's going to be the force that she's going to apply. And then she's going to build a vector3 out of those components.
Movement X and movement Y. These should be private, like the previous variable, float type, which is short for floating point or decimal point value. These give you more precision than a whole number or integer value. You can then reference these values inside of onMove and assign these values of movement vectors X and Y. In onMove, add the following 2 lines of code. Movement X equals movement vector dot X, semicolon. Movement Y equals movement vector dot Y, semicolon.
Not doing it this way.
Excellent. The second reason you were getting an error is because the movement vector variable was created inside of onMove. That means it's what's called non-existent in the current context, as it was inside another method. To fix this, you can combine the movement floats you just created inside of fixed update to create a vector3 variable. This will take 0 as the Y value because the ball needs to move along the X and Z axis in 3D.
Stupid. Well, we're going to basically do the same thing, but we'll just operate off of what we already have here. So we have our movement X and movement Y. They are contained inside of this input vector. Input vector dot X is the X, input vector dot Y is the Y. I only need 1 variable up here instead of 2. And down here, add force wants a vector3. So she's going to have us do a new vector3, passing in an X, a Y, and a Z. The X will be this dot, what I call input vector dot X. The Y will be 0. And the Z will be this dot input vector dot Y. And I'm missing a parenthesis there. So we are building a brand new vector3 with the right force on the X, the right force on the Z, and nothing on the Y, because he's not going up or down, right? He's just going. All right, make sense there? I'm not sure why she wants to have 2 variables up there. Whatever. Maybe there will be a good reason why, but I don't think so.
Space. In the fixed update function, add a new line at the top of the function and write vector3 movement equals new vector3, open brackets, movement X, comma, 0.0f, comma, movement Y, close brackets, and then a semicolon. The F after the value signifies that this is a float value. Next, use the new vector.
That is a somewhat important little point there, because we've learned in C++, as well as in Java, as well as in C#, we've learned about our primitive types, right? So we have byte, short, int, long, char, float, double, and Boolean. In C#, it's called bool. But what's the difference between a float and a double? They're both floating point numbers, right? The difference is the size, the precision. Typically, a double is 64 bits before the decimal point, 32 bits after the decimal point. And a float is typically 16 bits, I'm sorry, 32 bits before the decimal point, 16 bits after the decimal point. You can think of them as being kind of the floating point equivalent of ints versus longs. You want to kind of think of it that way. So, we could say, well, technically aren't doubles even more precise than than a float. But in any case, a lot of these things are left over from old C-style physics or C-style math. So the idea here is how do you explain to the compiler that you're talking about a float, not a double? That's where that F comes in, the 0.0 F. All right. Now, for us, I'll go ahead and update it here. But when I build a new vector3 this way, this will become a 0.0 F behind the scenes. If you just have the number 0, that is no more or less precise than 0.0 F. But we will, just as a reminder for ourselves, that is how you specify that this floating point number should be treated as a float, not a double, because it'll be a double by default. They had to pick one of them as the default, right? And double the better precision is the default value. Yet we're working with floats here again, because a lot of the older libraries with perfectly good math, right, were written in terms of floats. So that's why it's this way.
To 3-variable movement to add force to the rigid body of the player sphere. Revise the second line of code in fixed update to rb.addForce, open brackets, movement, close brackets, semicolon. Let's save the script.
All right, so what has she done here? She stored the X and Y separately up here when we stored ours as a single vector 2. Then down here, she created a separate variable called movement of type vector 3 and built it out of the X and built it out of the X and the Y here for the X and the Z coordinates of it. And then 0.0 for the Y movement on the vector 3. We didn't put that into a variable. We just passed it directly to add force. Well, marginally. Let's say marginally it could take longer. We'll have to see when would it be better to create the variable like this and then pass that variable in here than what we did by creating the vector 3 on the fly. Yeah. What if I had to use that vector 3 more than once? You create variables for things when you need that value more than one time. Okay. It's entirely possible that she's going down a path where she's going to use that movement vector. I don't think she will, but that she's going to use the movement vector for a couple of different tasks. And if that's the case, then it does make sense to create it once, store it, then use it for the 2 or 3 things that you need it for. All right, but for right now, we're using it once. I won't create a variable out of it. Oh, Ninja. So I just built my vector 3 inline here, which removes the ability to use that value again without recreating it later on. So if I do have to use it again, I probably would then move it into a variable, but I typically don't like creating variables unless there's a good reason to have a variable, which kind of goes hand in hand with this idea of why create 2 separate floats up here for an input X and an input Y, when I could actually just store it as a vector 2, and that kind of comes as a package deal. They're both right. It's fine. It's fine.
And then return to the Unity editor to give it a try. Use the play button to enter play mode and test. It works, but the player is moving really slowly.
All right, so hold on. Which because we're gonna have to put a multiplier on our force to make them move better. But my question is it the arrows or the WS? Oh, it works. Input works for both. Well, let's see when I come back in here and see it's compiling the script. So you got to make sure you save it in Visual Studio. Now I'll hit play. Oh, it's moving. Dun, 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 dun.
What happened?
Fell off the edge of the earth. He's falling. All right. I don't know about you, but that moved plenty fast for me. So here, just so we can get a better view of this, I'm going to go ahead and I'm going to move my camera up. And then I'm going to rotate it like that, just so I can kind of see it moving around a little bit better and possibly avoid it going off the earth. But we're going to be fixing some here anyways. But now you can see that it's, yeah, so I can kind of make it go in a circle, but it's pretty slow. And, you know, you can kind of tell that the force is being applied over time to this rigid body. So because of that, if I go too fast in one direction, I won't be able to stop it. It's kind of like a semi-truck barrel. And that's why, like in the mountains, they have the runaway truck things with the sand pits. Seen those? Oh, difficult to watch. All right. All right. So we're going to be adding some sort of speed multiplier to this. So we can make a guess at that here. I'm just going to multiply this by 10.0. My guess is she's probably going to make that a public variable inside of Unity so that we can adjust the speed of it if we want. In fact, actually, let me just show that to you real quick. I'm going to come up here and I'm going to say public float speed. So up top here, I've now made a public variable of type float, and its name is speed. Okay, now I can give it a default value, 10.0f, for example. I don't know if that's going to be too little or too much, but in any case, by making this guy public, it then exposes it to the Unity editor. And if you remember last time, I mentioned something called the model view controller, MVC. Okay, the model view controller says it's a good idea to keep your controllers, your data, and your view in separate places, and then come up with interesting ways of getting them to talk to each other. This is that interesting way of getting it to talk to each other. By making this public, if I go back over here to Unity, I click on player, we'll go down to our script here. Notice I now have a thing for speed. So I can change that value in there through the editor. Super Ninja. Oh, get it. Ah! Okie dokie. Well, that was a train wreck there at the end. Okay, so she's going to go in that direction at some level, right? Based on my gaming abilities, we might have put up side walls. kind of keep me on the playing field. Yeah, exactly. All right. Questions, comments, concerns, bribes. Yeah.
If your ball is not
I'm guessing maybe something you don't have your player input thing attached or something like that.
Yeah. Script is not easy.
Probably doing something wrong. I almost promise you're doing something wrong.
Yeah, I know.
Yeah, I don't mean I'd have to look at it and screw around with it, but it's probably something fairly simple. All right. So I will see everybody after. Well, actually, remember, I think I told you this before. After break, the 3 classes that week will be on Zoom only. All right. So, but we will have class. So next week we're on spring break. This Friday, you have your exam during class time. I'll be on Zoom. I'll be on Slack rather. The week after break, our Monday, Wednesday, Friday class does meet, but we meet on Zoom, and I'll send out a reminder of that. Yeah, I'll be holding class from the Caribbean.
Yes.
Using Tesla Starlink internet to test how well that works for Zoom.
It's so fun trying to speed up to like 10,000.